Our next speaker is Steve Pritchard from Premier Nutrition, who I think the conference, the committee chairman, referred to as our backstop speaker. So welcome, Steve, to EPIC. Thank you for agreeing to be one of the presenters. Steve, again, many of you will know, he heads up the team at Premier Nutrition. Premier Nutrition are well known for providing support across all species and nutritional support across all species. Steve is a former Nuffield scholar and past chairman of the Nuffield Poultry Group. Been with Premier Nutrition for 23 years. Steve actually helped me get a job in the poultry industry a number of years ago, so he's a good, he's an all-round good chap. So, Steve, welcome to the stage.
Thanks, Gary, and I've been regretting it ever since. So, we are talking about innovation and efficiency, but what I want to do really was we had the Daves this morning, and it's really great for me to be able to open up the Young Guns session. Really pleased to do that. Stephen Lister said, and he showed this earlier, which is, he says, if you knew what this was and you could remember this, that you actually don't qualify as a young gun, and I'm afraid I do. But anyway, we'll carry on. I'm actually going to be a little bit of a party pooper because I think innovation is one of the most overused words in business in general. And it's also extremely widely used within the poultry industry. And if you just do a sort of a run through of websites of poultry businesses, you'll see innovation used again and again and again. I think we all feel like we have to be innovative, but actually true innovation comes from a small number of very exceptional individuals, and David sort of alluded to some of that earlier. But I think success really relies on recognizing good innovations and putting them to good use. And I'm going to talk about this guy a little bit. This is Jim Collins, for those of you that don't recognize him. He's a business guru. And one of the things he does is he looks at businesses and what makes them successful. And one of the things he's shown is that the most innovative companies are not always the most successful. It's the companies that actually focus on the basics that are successful. So my message is innovation is great, but be open-minded and don't beat yourself up that you feel like you've got to be constantly innovative. Use innovation, but think about getting the basics right. And Jim points this out in a number of his books, but Good to Great is probably the most common one to read. And Jim also likes a good quote. So given our speaker tonight, I thought I would pick this quote, and it's from Roald Amundsen. He's Norwegian, so I will read it for you because it's in Norwegian. Victory awaits him who has everything in order. Luck, people call it. And defeat is certain for him who has neglected to take the necessary precautions in time. And this is called bad luck. And this refers to the race, if you want to call it a race, to the South Pole. And what I want you to do is to think, I want to encourage you to make sure that you do get the basics right, and don't be seduced by innovation just for innovation's sake, but use innovation, put it to good use rather than using it just because it's shiny and new. What I wanted to do was just to recap over some of the innovations we've seen from a nutrition and health point of view over the last half century. And I'm going to go back before my time. Even as a young gun, I didn't go this far back. But we started back in the 50s, the introduction of the single amino acid, crystalline amino acid methionine, coming available commercially and being used in diets, and it revolutionized how we feed birds. Move on to the 70s, we get another amino acid and we start seeing common use commercially of the amino acid lysine in diets, and we also saw the first ionophore anticoccidial coming into play. Skip another 10 years, the 80s were great, we were remembering them last night. Cereal enzymes, so we took this from the brewing industry, using enzymes applied to feed to improve the digestibility of the cereals that we use. Skip another 10 years, and we started to use digestible amino acids in terms of commercial formulations, and it was around that time also that we saw the introduction of the first ionophore chemical combi anticoccidial, and that revolutionized the way we could deal with the removal of growth promoters at the time. Skip another 10 years, Enzymes again, this time phytase enzymes, enabling us to use the plant phosphorus in the diet more efficiently and reducing cost in the diet and improving overall digestibility. And then my final one on here is about recognition of fibre as a nutrient. Nutritionists always used to ignore fibre. We thought it wasn't important. We've seen very clearly in the egg sector that fibre is an important nutrient, and it's also increasing in focus in terms of gut health for broilers. So we'll see more of that. And I think what you can see from this is that it's not a very long list. You might want to add some of your own to this list, but what we can see is that these innovations come along every 5 to 10 years, not every 5 minutes. So what I want to do now is just think about what we might expect over the next 5 to 10 years. And we've heard it already this morning. I think we need to be thinking about precision, and that should be our focus, getting the detail right, getting the basics right, going back to what Amundsen was saying. And in terms of precision feeding, getting more precise about how we deliver nutrients to the bird, but also, again, we've heard this morning about the sustainability, using the Earth's resources to the best effect. And what we want to try and do is feed that bird in terms of getting the supply of nutrients right without deficiency or excess. So the first area I'm actually going to look at is more of the same. And young guns all have tattoos these days, and if you're a young gun nutritionist, you have an amino acid tattoo. And we all need amino acids. Amino acids are the building blocks of protein. The bird uses them to produce meat and eggs and other metabolic requirements. And the key in terms of amino acids is providing the correct balance. And we want to provide that at the different stages of production of the bird. And how we tend to do that is we use something called the ideal protein concept. And what we do is we look at the range of essential amino acids and we fix a profile relative to lysine to say this is the ratio of amino acids that we want to provide to the bird in the feed. And this is just an example of a typical broiler looking at the various amino acids relative to lysine. And what we try and do then is we try to formulate a diet that matches that profile as closely as possible, avoiding both deficiency or excess. And in a conventional diet, that's fairly easy because as well as the traditional raw materials that we might use in the diet, so we've got cereals, soya, sunflower and rapeseed, we also have synthetic amino acids or crystalline amino acids, lysine, methionine, threonine, tryptophan and valine. And what we do in the diet, if we look at a broiler diet will typically, and a turkey diet for that matter, will typically contain the top 3 of those, occasionally with a little bit of valine as well. And then a layer diet will generally contain lysine, methionine, maybe a little bit of threonine, and very, very occasionally a little bit of valine. We don't tend to use tryptophan in UK diets because wheat contains quite a lot of tryptophan, so tryptophan is rarely limiting. Our issue in terms of progress for our typical broiler diet is that, and one of the reasons that we're not using lots of valine in broiler diets is that what happens with broiler diets is we get 3 amino acids all becoming limiting together. So we've used our lysine, we've used our methionine, we've used our threonine, but we're not using valine because when we try and put valine in, we very quickly hit the next limiting amino acid, which is isoleucine. And if we try and push the isoleucine value up or levels up, what happens is we see a rise in leucine. And I talked about deficiency and excess. If we see a high level of leucine, it's actually counterproductive, and you get an adverse impact on performance. And so this makes life very difficult for us. What we need is more amino acids. Now, the good thing that's happened this year, and is going to continue over the course of the next year, is that in addition to the 5 amino acids I've already mentioned, we're also going to get commercially available isoleucine and arginine. And this enables us to take a big step forward. We've been waiting for this. You know, the suppliers of these products haven't understood why we can't use valine. Well, they have understood, but it's taken time to get isoleucine and arginine together. What does that mean, and what does that look like for a typical broiler diet? So this is a trial looking at a broiler finisher and taking the control at 19% protein with the kind of standard addition of amino acids, and then coming down in 1% steps using more of the single amino acids in order to balance the diet. And what you can see from this is that by coming down in 1% steps, we see no adverse impact on live weight. We see no adverse impact on feed conversion. But what we do see, and comes back to David's point, sorry, when I say David, it could refer to any of the previous Davids, but David Brass's point, we see a big reduction in the excretion of nitrogen through the manure, but also a big reduction in nitrogen volatilization, so going into the atmosphere. And that has a big potential impact in terms of how we go forward, given the challenges to the industry. Now, you could do exactly the same thing in a layer diet, just that the mix of amino acids would be slightly different, and we tend to run layer diets at slightly lower protein in the first place. But really good potential, and I think over the next 1, 2, 3, 4, 5 years, we will see these new amino acids becoming completely commonplace in diets, and that will be the next step forward for us, and there are more amino acids coming in the future. What it means is that we'll be able to drive down proteins. It means we'll drive down our excretion of nitrogen, and it'll also reduce our reliance on soya, because what's driving soya into these diets is the requirement for things like isoleucine and arginine. Now, I mentioned soya because it's one of those emotive subjects, and I don't really want to get into it today. There's a lot of media focus around the plight of the Amazon rainforest and sustainability and carbon footprint, and that really is a whole different presentation. But what I wanted to do was just kind of get a bit of a reality check of reminding ourselves what we grow and what we grow in the world and what we grow in Europe. So this is the world production of oilseed meal. So so you take the seed, take the oil out of it, and this is the meal that's left, and this is what we use. This is the byproduct of oil production. And what you can see is that soya absolutely dominates world oilseed production. There's a small amount of rapeseed and a small amount of sunflower, but 70% of the oilseed produced is soybean. If we then focus in on Europe, it's a slightly different picture in that rape and soya are more evenly balanced, but actually a lot of that soya is grown outside of the EU, and the beans are imported and it's crushed in the EU, which is why it appears in the oilseed meal figures. So what this is telling us is we're not going to get away from rape and soya particularly anytime soon. We've got these for the long term, and we need to think about if we're trying to reduce soya levels, it's going to take time to do that. If we look at what other crops we grow in Europe, and these are the total seed figures rather than the meal figures, rapeseed dominates in Europe, followed by sunflower. We don't grow much soya. And then the only other crop that gives you any kind of protein contribution, or crops that give you any other protein contribution, are peas and beans. And when we look at what's happening agronomically, we know that rapeseed is very challenging in terms of the problems with slugs and flea beetles. Sunflower and soya are increasing, but peas and beans are fairly neutral. Now, the EU recognises the issue here that we need to grow more protein crops within Europe. And there are a number of countries signed up to the European Soy Declaration to try and collaborate in order to get more protein crops grown, but that's going to take time. In the meantime, there are other projects going on to look at what else can we do, and I suppose the first thing to do is say, well, how can we make better use of what we've got? And again, EU project, Feed a Gene project, and one stream of that is just looking at taking rapeseed. You extract the oil, you're left with a meal, and then you treat that meal in order to concentrate the protein from the germ, from the hulls, and you produce a high protein, high digestibility ingredient. It looks interesting, but at the end of the day, it's still got to compete with soya, and soya is still that dominant oil seed that we're dealing with. So interesting stuff, but it's going to take time. Now, I know with Gary in the chair, Gary gets very excited about novel ingredients, and we are talking about innovation. So I feel obliged to talk about potential novel ingredients, despite the fact that at the moment we're dominated by soya, rape, and sunflower. Laugh a little bit as to whether meat and bone meal is novel, because in my lifetime it wasn't novel. But we need to think about meat and bone meal. It looks like it's coming back, and it looks like it's coming back probably next year. The question, I think, and there are people in the room that might be able to answer this better than I can, is what will the public think about it? What will consumers think about it? What will retailers think about it? Will they think about mad cow disease? Or will they think, do you know what? This is really intelligent recycling of waste material, and embrace it. It'd be interesting to see how that plays out, and maybe we can talk about that later. I think the key thing to note is that people have this sort of historic view of meat and bone being some fantastic ingredient. It's going to have to be processed really well in order to secure its kind of hygienic properties, and in doing that, that will damage the protein. So this isn't going to be a magic ingredient. It's going to be an interesting ingredient, but don't hold your hopes for it to be something absolute, some kind of wonder product. In any presentation about novel ingredients, we have to talk about insects, and are insects coming to a feed mill near you anytime soon? Maybe they will do, because again the legislation is changing, so we think that from next year we will be allowed to use insect protein meal. So that's one hurdle jumped. But there are two great big hurdles which we know about, which are the scale of production and the cost of the product. So personally, I can't see insects having any impact on mainstream production for some time to come. Loads of interesting projects, some good stuff on feeding live insects, but it's going to take a long time to get that scale and cost down to a level where it's going to compete with soya. There might be some specific areas where you would have a targeted product. Next one is quite interesting, green biomass. Now this is taking grasses, clover, lucerne, and harvesting the soluble protein from them. And actually when you look at the amino acid profile of those soluble proteins, it's actually really good. It has a very good fit with what the bird needs. And I put an example up here from the pig industry. This is some Danish work looking at putting this product into organic pig feed. Now, the cost is helped with this because obviously all the other raw materials in an organic diet are much more expensive, and so these things can feature without having to compete with that hard soya price. So an interesting area. We can grow grass fairly well, so it's one to watch. There are some projects going on the poultry side, and I think over the course of the next 5 years we might see some further developments on that, which will be interesting. Final one on my list is microalgae. Again, it sort of comes, it's one of those ones people like to talk about alongside insects. I've actually used a ruminant example here just to show a bit of gender diversity. But this is looking at microalgae replacing soybean in ruminant diets, but there's no reason why we couldn't do it in poultry diets. Same issues as we have with insects, in that what you've got is high cost of production, and the scale is very small at this stage. So again, a long way to go, but maybe in the next 10 years we'll see something happening there that will be of interest to us from a commercial perspective. So, I actually now want to take you back to basics and throw out some challenges for all of us. This is not a challenge from me to you, it's a challenge, or challenges to us as an industry. I'm going to throw 3 challenges out there about how can we get the basics right and how can we feed our birds more precisely. And it's one of those things we're saying, this is about innovation. If you want a light bulb moment, maybe staring in the mirror is going to give you that light bulb moment. So this is me staring in the mirror with you guys together. And challenge number 1 is, how do we feed our broilers more precisely? If we draw the requirement of a broiler expressed as a percentage of the diet for amino acids, and we could pick any amino acid, but the key thing is expressed as a percentage of the diet, it looks something like this. And we've known that. It might not be a perfectly straight line, but it's something like that. How have we been feeding it for the last X number of years? We feed it in steps. We know that we have periods of underfeeding, and we know that we have periods of overfeeding. Now, some people manage to smooth off the corners of this by using whole wheat, but generally speaking, as an industry, we feed our whole wheat in steps. How often have you said, or have I been asked, or been told in reality, it all goes wrong, Steve, when we go on the finisher, or it all goes wrong, Steve, when we go on the grower, or things actually come good when we get on the withdrawal? Well, if we had 2 diets, a high-spec starter and a low-spec with a finisher or withdrawal or whatever diet, and blended them together on a daily basis to match that line. The technology exists to do that, but very few of us are doing it. And my question is, why aren't we doing that? Because we would feed that bird much more efficiently, much more precisely. Okay, challenge number 2, I'm going to skip to layers now. And how do we feed our layers more precisely? And this is talking really about as birds come into lay. And I was really encouraged by David's presentation, because very few people know what their birds are eating as they come into lay. And David alluded to it, is that birds that haven't got enough food get a bit hangry. So you've got that issue in terms of getting birds that then start pecking. But also, if you overfeed them, they're not going to be efficient. So the question really is how can we do that better? The technology exists, but if we take a moment in time and look at the implications of it, a bird coming into lay, let's say in its mid-20 weeks, it wants 1.24 megajoules of energy. Make the sums easy. If it's eating 100 grams, that diet needs to be 12.4 megajoules. That's a real high energy layer diet. You could possibly get there with a little bit of a squeak, but that's real high. Get another 5 or 10 grams feed intake, and feeding that bird becomes much easier. But if we don't know what the feed intake is, we don't know what diet to feed. The key thing is, if it's on 100 grams, then actually what that's telling us is you need to encourage that bird to eat more. And if you get it eating more, you can feed it a lower energy diet. If you feed it a lower energy diet, you can get more fiber into that diet. If you can get more fiber into that diet, you can help control behavior, which should be our long-term goal in terms of keeping feathers on birds and stopping birds from pecking. So let's concentrate on understanding what our birds are eating accurately, particularly as they come into lay. Challenge number 3, and this is the last one, is for layers again, and it comes back to how do we feed our layers more precisely. And we've talked about this. What are the geneticists doing for us? They're giving us this potential for a 100-week cycle. They're giving us the potential for a bird that can lay 500 eggs. And there are going to be some challenges with that, not least how do we work on the immunity of the bird to carry it through to that length of cycle. But there's some simple stuff as well. We have known forever that the bird exhibits a specific calcium intake or appetite later in lay. And so if you feed the bird separate calcium, it will eat more limestone and more calcium towards the end of the day as it's getting ready to produce a shell overnight. We've looked at this for years and done nothing about it. That's not quite true. But there are simple solutions. You go to other countries and what they have is a setup where they have a simple small limestone bin alongside the traditional feed bins, and they set that up, they gear that up to deliver large particle limestone to that bird later in the afternoon. Really, really simple. You don't have to be all fancy and have split feeding. It's just a really simple solution to a problem that we've known about forever. Okay, I'm going to stop poking you with a stick now and just come back to Amundsen for a moment and finish really by encouraging you to think about Amundsen and what he said, which is, and I'm going to paraphrase it again out of the Norwegian really, which is, if you get the basics right, then you've got every chance of success. The more detail that you have, and we've heard that this morning, the more detail that you have, the more precisely we can deliver what the bird requires, and the more precise we are, the better use of our resources we're going to make. And I leave you with that. Thank you, Chairman.
Thank you very much, Steve. That was very, very good. And you kept it simple. It's too easy for a nutritionist, I think, to overcomplicate the message. You kept it very simple, very clear. Thank you very much, Steve. Spot on. Questions, please, from the floor. I think we'll defer to Slido on that basis. Steve, I don't know if you can see the
yeah, got it here in front of me.
Question there. I'll read it out if I may. Are there any new innovations in feed and nutrition to help support and sustain the production of large eggs whilst extending the laying cycle? For those in the poultry meat sector, huge challenge, egg size. In the egg sector, an eternal problem, challenge, conversations that you'll be having with producers. Your thoughts on that question, please, Steve.
Okay, I mean, there are lots of things we can do, whether they're particularly innovative, but they're things we've known about for a long time. So getting large eggs in the first place, you're much better off trying to do that in the rearing stage than you are once the horse has already bolted into the laying stage. But really, precise delivery of nutrients, calcium, phosphorus, vitamin D, and your trace elements is key to getting a good shell around the egg. If you're pushing for larger eggs, then you need to make sure that you have a good shell around it at the same time. So focus on the rearing period in order to get a bird that's going to deliver you those large eggs. and then focus on the nutrition delivery in order to keep a good shell around them once you've got those large eggs delivered.
Thank you, Steve. Any questions from the floor? Steve, can I ask, thank you, can I compliment you firstly on indulging myself and everybody in terms of the novel protein slide that you gave. I think that was very particularly informative. Not necessarily a question for you, but given that you're on the stage, I will ask you this question if you don't mind. Do you think, given that scale and cost are the key challenges from an insect protein point of view, do you think the UK is doing enough to lead the way in terms of development of this novel protein? At the moment, as we know, we are largely reliant on imported protein raw material. This surely gives us an opportunity to be on the front foot and produce homegrown protein for poultry diets. So, as I say, more of a political question, so forgive me, but do you, in your view, do you think the UK is doing enough to be innovative in that area of alternative protein, please?
Yeah, that's a good question. I think that there are lots of great projects looking at live insect stuff because we've had this issue with the legislation. And so there are a large number of projects looking at turning waste into live insects to use as a feed source. The problem with those things is how nutritionally do we capture the value of that in a way that we can then balance that with what we're doing through the diet. So it's about how we deliver that precisely to the bird. In terms of the actual insect, the processed insect protein, then most of that work is going on overseas. So there are lots of projects both in Europe but in other parts of the world. And when I say Europe, particularly places like Poland, but also South Africa. And so are we doing enough? I think there's a lot going on. We could always do more, Gary. I think my concern really is that where we need to get to is understanding what we're competing with. And we're competing with that dominant protein source of soya. And so the question needs to be answered as to whether we can ever get to a scale that can compete with soya or not.
Thank you, Steve. We've got one last question. We've got three great questions on the board there from Slido. In the interests of neutral, I'll go with the middle question, if I may, Steve. And that middle question is, can we do more to use water? So it's jumped up to the top question. Can we do more to use water intake as a carrier of nutrients to complement the future diets that you've outlined in your presentation?
Yes, another good question. Potentially we can, and if you think about how we can deliver stuff precisely, it gives you the chance to do things during the day or at certain times of the day. So from that perspective, yes, we all get very nervous about nutrients in the water because we've spent years focusing on water hygiene. So I think one of the challenges of delivering nutrients through water is how can you do it without compromising the hygiene? But it's an area that could be developed because there are things that you could do in order to deliver nutrients at a specific time. So yes, it's an area of interest.
Thank you, Steve. We've got two other questions. Unfortunately, in the interest of time, we haven't got time to ask them, but perhaps we'll take those up with you offline, Steve, and we can maybe get your thoughts in response to those two questions on the board and get it onto our website at some point. So a round of applause, please, for Steve. Thank you.